Okay, so now let's move on to question number 8. How do you calculate the oxidation number of an element in a compound? So the oxidation number is the charge an atom has if it was ionized. So we know an atom is oxidized if its oxidation number increases during a reaction. So on the other hand, if the oxidation number of an atom decreases during a reaction, we know that this atom was reduced. Let's see what our junior tutor said. Okay, so the oxidation number is the charge that an atom would have if the compound was composed of ions. They play an important role in the systematic nomenclature of chemical compounds, and it's useful to follow chemical reactions by looking at changes in the oxidation numbers of the atoms in each compound during the reaction. So here they also gave helpful rules to help us determine oxidation number of an atom. So here are the main rules. So we know the oxidation number of an atom is 0 if it's in a neutral substance that contains atoms of only one element. So when you have a gas or a pure liquid, aluminum metal, like a solid, they all have an oxidation number of 0. The oxidation number of simple ions is equal to the charge of the ion. So for the sodium ion, it has a +1 charge, so its oxidation number is +1. Similarly, chlorine has a -1 oxidation number. Oxidation number of hydrogen is +1 when it's combined with a non-metal. So when it's with carbon, nitrogen, or oxygen, it has a +1 oxidation number. But when hydrogen is combined with a metal, so when it's in a hydride, then it has a -1 negative oxidation number. Okay, so they have metals in group 1A have an oxidation number +1. Similarly, elements in group 2A on the periodic table have a +2. And typically, oxygen usually has an oxidation number of -2, but there are some exceptions when it forms a peroxide, then it only has an oxidation number of -1. Elements in group 7A often form compounds so basically fluorine, chlorine, bromine, they all have oxidation numbers of -1. What's also helpful to know is that oxidation numbers in a neutral compound should add up to 0. The sum of the oxidation numbers in a polyatomic ion is equal to the charge on the ion. And also, elements towards the bottom left of the periodic table more likely to have a positive oxidation number than those towards the upper right. So this was a very informative solution. It is also correct.